Okay, for this one, we're looking at percent change. That's what this section is all about, is percent change. So what you really need to know about is that percent is equal to the amount of increase or decrease divided by the original amount. But if you times it by 100, you're going to get the percent. So a coat is on sale. The original price of the coat is $82, and the sale price is $74.50. What is the discount expressed as a percent change? So what you do is you do this. Okay, you take your 82, right, and you subtract 74.50, and you're going to divide that by the total amount, which was the original amount was $82. Okay, and then we times that by 100%, and you get it. So 82 minus 74.50 is $7.50. If I divide $7.50 out of 82, I get, and then I times it by 100, I get a 9%. So what percent is that? That's decreased by 9%. Okay? Real easy. You got it, do it real quick. Store buys an electric guitar for $295. Okay? A store buys an electric guitar for $295 and then marks the price up to $340. All right? What is the markup expressed as a percent change? So you're going to take your new amount, so your new amount, which is $340, minus your original amount, which is $295, and we divide that by my original amount, which was $295, right? And then I'm going to times that by 100%, and now I'll give you my percent. Now I know this is going to be an increase because it's bigger, but 340 minus 295, well, that's 45. So I'm going to do a 45 divided by 295, and then I times it by 100. And if I do that, 45 divided by 90, or 45 divided by 295 times 100 is 15%. So this is a 15% markup on the price. Okay? So you have got it. Why don't you pause the video and do it. So where does this come into play? You've probably heard of your science teacher talking about relative error, and this is an example of where relative error comes into play. Basically what that is, the relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual compared to the actual value. So you can see that the relative error, also known as percent error, is a lot like what we've already been doing. So if we look at this, a decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is percent error in the area estimated? Well, first thing I'm going to do is 5 by 8, that's 40 square feet. Okay? And then my 4 by 8, that's 32 square feet. Okay? So I'm going to do this. Measured of the estimated, which was the 40, right? So I'm going to take the absolute value of 40 minus 32, and I'm going to divide that by the actual, which is 32. So 40 minus 32 is 8. Absolute value is 8. So I get 8 out of 32. Then we'll multiply that by 100 for a relative error of 25%. So I'm going to bubble in C. Okay? You got it. Why don't you do it real quick? Last problem, or actually second to last problem. So finding maximum and minimum dimensions. You are framing a poster and measure the length of the poster as 18.5 inches to the nearest half inch. What are your minimum and maximum possible lengths of posters? Okay, well, let's see. So you got 18.5. So if I do 18.5, and I take away that half an inch, that's a 0.5, wait, no. Oh, it went to the nearest half inch. So I'm going to take half of that, quarter inch. So 18.5 minus 0.25, that's going to get me up to 18.25, as that's one maximum amount. And then I could also go a little bit over that and say 18.5 plus 0.25, which would be 18.75. All right, so those are my two max and my min. Now, why did I choose to do that? Because it says to the nearest half inch, and it says the maximum amount is 8.5, so I took half of that, a half an inch. All right. Looking at the next one. I believe you guys got it. Do it, and we'll look at problem number 5 right now. The greatest possible percent error. All right, the diagram at the right shows the dimensions of a gift box to the nearest inch. What is the greatest possible percent error in calculating the volume? Okay, the volume of the gift box. Okay, so the measured volume, so the greatest possible, it would be, you can go within a 0.5 inches. So let's do this. Let's say volume is equal to L times W times H. So we just go ahead and take the volume and say it's 5 times 6 times 12. So the actual volume of this is 360. Okay? The actual volume is 360. So what I want to do is, and it says, okay, what is the greatest possible error in calculating the volume of the gift box? So when you look at the percent error, you want to be within 0.5 inches, I believe. So there's a half an inch. So the minimum I'm going to go would be 4.5 times 5.5 times 11.5. And if I multiply those three together, I get 284.625. And the maximum error, if I go by a half, if I added by a 0.5, would be 12.5, 6.5 by 5.5. And when I do that, I get 446.875. All right, and now I'm almost done. What I got to do now is find the differences. So I'm going to take the absolute value of 284.625 minus 360. I'm going to divide that by 360. And I'm going to do 446.875 minus 360. And divide that by 360. And if I do those calculations, let's see, this one gets me a difference of 75.375, so 75.375 divided by 360. And this other one gives me 86.875, and I'm going to divide that by 360. So which one am I going to use? I'm going to use this one. This gives me the greatest percent error, and that comes out to be about 24%. So you haven't got it. Why don't you pause the video and do that, and we'll talk about any questions you might have in class. Just go ahead and check off on your math success where you're at. Are you good with these definitions? And do you understand how to do this stuff? All right? I look forward to seeing you in class tomorrow, and may the force be with you.